Hi everyone, and welcome to QBranch's video on programming your FRC robot using LabVIEW. This is Burdett, and in this video I will be walking you through how to add a motor, solenoid, or limit switch to your program. This is the second video for QBranch, so we are going to start from where the installation and drive video left off with our code. So let's assume you have designed your robot and you know you're going to need a motor to do something with an axis on a gamepad. Go ahead and open the Begin VI so we can tell the computer what to expect. First, let's set up that gamepad. Let's just cheat and use copy and paste. Work smarter, not harder, right? Okay, let's get that motor started. Go get the open icon for the motor inside the WPI Robotics library and then the actuators subfolder. Now time to teach you a trick for when you get stuck later. Instead of going back for more, let's just copy and paste that open icon. You should be aware that you don't want another open icon, but you want something from the motor palette. So, instead of hunting down the icon in the library, right-click on the second open icon and then move your cursor to Replace and then Motor Palette. This will find the set of motor icons for you and choose the icon with the arrow going into the numbers page. Under the open icon, you will again need to select the type of speed controller you'll use on the robot. I will choose a Victor SP for this tutorial. Other speed controllers allow other options, such as the Talon SRX, which uses CAN bus wiring instead of PWMs for sending information. We'll save that for a more advanced video, but for now, let's get this motor up and running. Just like the previous video, we will need to tell the computer what we plan to name this motor and where to find the information. Start by moving your mouse over the open icon and right-click on the blue dot to create a constant in the blue box. Unlike the joysticks, now your computer is going to ask for what PWM slot to send information. These are on your RoboRio, and the drive motors likely already took up slots 0 and 1. So let's make this one PWM2. Next, move your cursor over the arrowed icon and right-click on the pink dot to then create a constant. I'm going to call my motor Shooter with a capital S and no spaces anywhere. Once the two icons are wired to each other, we are good to move on to the teleop phase. Go back to the small screen and double-click on the teleop VI. In case this is not already open, remember to press Ctrl and E at the same time to see the code underneath the gray face. Here we will need to call back that same motor we just brought into existence in the Begin VI. To do this, let's go get that motor palette and get the icon with the arrow coming out of the numbered page. Next, from that same palette, you'll want the Set Output icon. Make these two neighbors and let's wire them up. Reminder that you need to set the name of the motor to the exact same name used in the Begin VI. Next, we need to control this motor being on or off by the values from a known axis. Choose your axis based on your preference, but here's how to wire the control. Depending upon your setup, you may need to call back the gamepad you made in the Begin VI here in teleop. I love copying and pasting code, so this will be no different. Now, let's connect the output of the axis we want to set the output icon of the motor we want to control. Finally, be sure to create a constant at the axis so you know which axis is used to control the motor speed value. Lastly, let's go to the Finish VI and close out the motor. Use the exact same name as in the Begin and teleop VIs to ensure no hiccups are in the system. If you instead want to control the motor by the push of a button, we will need to add in a true-false gate to turn the motor on and off. Let's go back into the teleop and try this out. Delete that wire from the axis to the set output icon of the motor. Left-click once on the wire and then press Delete. Now we're going to find a true-false gate in the tools. This is not in the WPI Robotics library, but rather in one of the top folders. We're looking for a triangle with a T and an F and a question mark inside. Go ahead and left-click on this icon and put it into place to the right of the button array. Reminder that the orange lines are for the axes and the green lines are for the buttons. Wire the button terminal to the true-false gate at the question mark. Next, right-click on the true orange dot to create a constant. The number you put in this box corresponds to the percentage of power you wish to give the motor when the button is pressed. Entering a 1 means 100% power, and entering a 0.5 is 50% power. Entering a negative value means the motor will run in reverse. If you want to have one button forward and another reverse, you're going to need to expand down your button array and repeat this process. You also need to right-click on the false orange dot on our gate and then create a constant. This is the value given to the motor if the button is not pressed. Often this value is 0. As a pro tip, if you're programming an intake system, you may want to make this value a small amount like 0.1 or negative 0.1 to act as a holding voltage. This value doesn't really move the motor, but it makes the back drive a greater challenge, and that holds your game piece in your robot. Okay, finally, wire the right side of the true-false gate to the set output icon of your motor like we previously did with the axis. There are a lot of fancier things you can do here, but this will get your motor up and running. But what about solenoids? Well, everything is the same with the solenoid except for you're using the solenoid palette instead of the motor. You will need to know if you are running a single or double solenoid during the begin VI, and then solenoids are not controlled by axes and teleop. In the begin VI, you will need to identify the location of information as the solenoid positions on the pneumatics control module, or PCM, instead of PWMs like we did with the motor. For single solenoids, you only need one slot, which while doubles, you need 2. Logistically, it is best practice to go in sequential order and make them neighbors. So if you're using a double solenoid, use slots like 0 and 1 instead of 0 and 5. You'll thank yourself later. Let's get to that teleop. Use a button to control them with either forward, reverse, on, or off being your values instead of numbers. These special blue boxes are not generated on a true-false gate, so you will need to create them on the set output icon for the solenoid and then copy and paste them over into the true-false gates like you see I'm doing here. All of the steps are the same except for replacing the word motor with solenoid and those small differences I mentioned earlier. Lastly, if you want to add a sensor or like a limit switch, then it's very similar. At the begin VI, we will open and then leave that same arrow pointing to the numbered page, but for a switch. We will need to name the switch and tell the computer what DIO port, just like a PWM slot, to locate the information. In teleop, we use the limit switch to activate something or change the value of a motor, etc. And in this example, I am using a true-false gate to set the value of a solenoid. So, this code reads that if the switch is activated, the solenoid will fire forward, and if not, the solenoid will fire reverse. So, as always, be sure to close out the switch, solenoid, or motor in your finished VI. There! Now you got motors, solenoids, and switches. Good luck, and thanks for watching.